This is our Follow the Line challenge robot, and we named it Scorpio. It was made by me, Andrew C., and my partner, Arthur Sokol.
The objective of the Follow the Line challenge is to construct a robot that could follow a line using a light sensor by itself and complete turns to make it to a tray and launch pennies into the tray. Some of the constraints included one NXT, 3 servos or motors, 1 ball bearing, the Mindstorms 2.0 software for programming, and the Lego parts only.
Some of our problems were that the robot would not turn, so we decided to increase the turning power. Our next problem was that the robot did not have a launcher, so we decided to build a basket-based launcher that would hold up to 10 pennies. Sometimes the robot would jump turns, so we lowered the turning power. And other times, the robot rods would bend, so we built a more stable chassis.
This is our video of our robot completing the challenge.
Here it's following the outside line, and it's going along the turns. It's turning here. We finished this in 30 seconds, which is the time that we were supposed to finish it.
At this turn right here, we often missed it and just kept going straight.
And
that's
now it
where we
goes
launched
pennies.
pennies. And we got a total score of 20, a near perfect score of 29. This is a picture of our program. Our program started with the ultrasonic sensor in the front, which is right here. If the ultrasonic sensor did not sense anything, it would move to the light sensor. If the light sensor was on white, it would turn, the motor on the right would turn slightly, or turn less velocity than on the left, and it would turn onto the black. And once it was on the black, it would do the opposite, turn back onto the white. Our robot was initially kind of walking, with one brake and one moving, and at the end of the line, it would sometimes be turned because it was moving back and forth so much, and also pennies would jump out. So I made it more like one motor would be 15 and the other would be 100. That way, it wouldn't be moving back and forth as much. Once the ultrasonic sensor sensed something, it would go to the touch sensor. When the touch sensor was not pressed, both motors would stop, and motor C would launch the pennies. This is motor C. Once motor C touched the touch sensor, the whole program would stop.
Some of our features and benefits are the ball bearing, which allows it to make smooth turns. Another feature would be our light sensor, which would allow it to sense the line and turn. Another one would be the ultrasonic sensor, which would sense when it needed to launch. And another feature would be our launcher and touch sensor, which would allow it to throw the pennies into the basket. Some of our reflections are that the project progressed quickly, and you always
had time to improve our project whenever we needed to improve it. Also, whenever we needed to make a decision about our project, me and Andrew listed our decisions and then chose the best one, and we always chose for the best. Some of the problems with this was that me and Andrew had kind of similar thinking, so sometimes we wouldn't recognize potential problems.
And in the end, we collaborated very well. Any questions?